Today we are going to talk about charge distribution, how we can distribute charge over something. As of now, we are talking about charges like distributions distributed over a place like this. So let's say it is 1 coulomb, this is 2 coulomb. So this distribution, this kind of distribution, we call it a special name that they are in different kind of packets or they are discrete charge distribution. So this is one kind of distribution which we are talking about when we were applying Coulomb's law to separate charges at separate points. But that is not a practical way. Practically, in practical world, you will get continuous charge distribution. So this charge distribution will be continuous, continuous. So the distribution will be continuous. What does that mean? Let's see. So for example, I have a wire here. Let's say this is a wire. So this is a wire. I want to distribute charge out of it and I want to be continuous. So one way to spread charge on this continuously, I will think like I'm applying it like a paint layer on it, a paint layer on it like this. So this is one way of distributing charge. Now, what is in it? What is special about it? It is continuous, right? If you cannot say that there are different packets. 1 coulomb is here and 1 point is here having 2 coulomb. So that is what we mean by continuous charge distribution. And they can be of two types. It can be uniform, like which I have drawn, smooth. Everywhere it has the same color density. And another way is discontinuous. Most of the cases which we are going to deal, we'll be talking about uniform charge distribution just like that. But in our copies and notebooks, we don't draw like this paint line. We show this representation. We do like this. If there is a wire, if I want to show, I will just show. If I want to distribute positive charge, I will show like this. This is a uniform charge distribution. How I'm showing it, I'm keeping these charges sign symbols equally spaced out so that you know the charge is continuous. We don't show it like what we have understood like a paint layer. That was for our understanding. Here is one note that don't think that there is a gap here. It is just a way of showing continuous charge. So there is no gap here. Okay, it is continuous. It's just like a paint. But to show in our copies, we show it like that. So if that is understood, we know now uniform charge distribution, it is like that. We show it like that. Now what about discontinuous? What is about it? Let's see. Again, I will take a wire. So this is a wire and now I'll paint it. But what I'll do now, I will keep this side on the left side some more charge. So you can see the density is changing. The line here, if you see here, if somebody asks, so you can clearly say that density of charge is more here. Density of charge is more here. And here, the density of charge is less. It is also continuous, but if you can see the density is changing, right? It is also a part of continuous, but its density is changing. It is not uniform, it is discontinuous. So that is the difference between the discontinuous and uniform charge distribution. If you want to think about in intuition basis, that you can say that uniform is like just applying one layer of paint everywhere, same density. And if you some parts you are applying more paint, some part you are applying less paint, so that distribution is kind of discontinuous. Again, in our notebook, we will not show like this, we're playing with the opacity or playing with this lines, how brighter it is. So we will not play with this kind of paint. What we do is we represent density changing like with the spacing out of these charges. So now if you see this area, you will say seeing this plus sign having more space, it means that the density of charges is less. And if you see here, they are very closely packed, or we can say they are having high density here at this particular length. But again, a small note, it does not mean there is a gap here. It does not mean there is a gap here. It is just our way of showing it. But because in our copy and notebooks, we don't draw like paint lines like this for the charges, we show them with charges having some space. And if we increase the space, what we are trying to show is the density is less. So don't confuse it that they are different point charges like we were doing in a Coulomb's law, that they are separated as points. So that is a different distribution, which is discrete charge distribution. This is discontinuous charge distribution, not the discrete one. There is no gap here.